नमस्कार विद्यार्थी मित्रांनो, बेसिक फिजिक्स स्टडी पॉईंटमध्ये सगळं विद्यार्थ्यांचं मी मनपूर्वक स्वागत करतो. आज आपण बघणार आहोत हा व्हिडिओ. बेसिक पॉईंट आपण याच्यामध्ये बघणार आहोत, प्रेशर, फ्लूइड ॲट द रेस्ट. मित्रांनो, आज आपण इथे पाहणार आहोत, पहा की इट इज द इम्पॉर्टंट टू अंडरस्टँड द डिफरन्स बिटवीन द सॉलिड अँड द फ्लुइड. Solids can be subjected to the shearing stress or the tangential stress as shown in this figure. Look this figure, shearing stress, and another is the normal stress. आपण दुसरी नॉर्मल स्ट्रेसची एक डायग्राम बघणार आहोत. याच्यामध्ये नेमकं काय होतं की सॉलिड्स अपोज द shear stress either the force of developing restoring force, and which means that the deformation are reversible or they require a certain initial stress before they deform and start flowing. And its behavior we will be understand in the 11th standard. Ideal fluids of the equations, or other hand we can say that the only subjected to the normal compressive stress, and another it is the tensile stress. अशा दोन टाईपच्या टेस्ट आपण याच्यामध्ये बघणार आहोत. तर याच्यामध्ये होतं काय मित्रांनो, when the solids oppose the shears stress either but the developing the restoring force, and which means that the deformation are the reversible or they require the certain initial stress before they deforms and start the flowing. We have studied this behavior of the solid in the elastic behavior in the next topic. The ideal fluids on the other hands can only be subjected on the normals compressive stress are called as the pressure. Most fluids offers a very weak resistance to deformation. The real fluids display the viscosity and so on. तर हा फोर्स बघा मित्रांनो की फोर्स ॲक्टिंग ऑन द स्मॉल सरफेस एरिया DA विथिन द फ्लुइड ॲट द रेस्ट. अशा प्रकारचा फोर्स आपल्याला जाताना दिसेल. आणि स्मॉल सरफेस ऑफ द एरिया DA. आता बघूयात आपण प्रॉपर्टीज ऑफ द सॉलिड्स. They do not have opposed number one, they do not have the deformation, they get the permanently deformed. Number second, they have the ability to flow. Number third, they have ability to take the shape of the container. The fluids exhibits the properties. This exhibits the properties because it can not oppose the shear stress when in the static equilibrium. This static equilibriums. मित्रांनो, अशा प्रकारे आपण त्याला बघणार आहोत. आणि त्याच्यानंतर फ्लुइड्स ॲट द रेस्ट, द ब्रँच ऑफ फिजिक्स विच डील्स विथ द स्टडी ऑफ with the properties of the fluids at the rest is called as the hydrostatics. In the next few section we will consider a small portion of the solids at the rest. Now for that purpose we have taken here two surface areas, and we study the pressure about that surface due to the extension of the fluid. A fluid at the rest exert a force on the surface of contact. The surface may be wall or the bottom of the open container of the fluid. The normal F exerted by the fluid at the rest per unit surface area A of the contact is called as the rest per unit force area A, and the pressure P is formula P is equal to the F divided by the, and fluid exert the force on the vertical surface. And vertical surface याच्यासाठी जर बघितलं आपण तर अशा पद्धतीनं व्हर्टिकल सरफेससाठी आपण कन्सिडर करूयात. आणि दुसरा जो आहे हॉरिझॉन्टलसाठी हा अशा प्रकारचा हॉरिझॉन्टल सरफेस एरियामध्ये प्रेशर ऑफ द फ्लूइड एक्झर्ट फोर्स ऑन द हॉरिझॉन्टल सरफेस एरिया. अशा दोन प्रकारचा फोर्स आपल्याला याच्यामध्ये दाखवता येईल. Thus the object having a small weight can be exert high pressure if its weight acting on a small surface area. For example, a force of 10 Newton acting on the 1 centimeter square, the result in the pressure of the 10 raised to power 5 Newton meter square On other hand, the same force of the 10 Newton while acting on the surface area of the 1 meter square exert a pressure of only 10 Newton per meter square. Now friends, the SI units of the pressure is Newton per meter square. Also 1 Newton meter square is equal to the 1 Pascal. The dimensions of the pressure is minus 1 in L, 1 in M and minus 2 in T. The pressure is a scalar quantity. Other common units of the measuring pressure of a gas are bar and the torr. The 1 bar is equal to the 10 raised to power 5 Newton per meter square and the 1 hectopascal is equal to the 10 Pascal. And in this way we have studied about the